that if I want the distance from this point to that line, that's a vertical line. So the distance is going to be a horizontal segment here because that's where it's going to form a right angle. And then all we have to do to find this distance, we don't have to use the distance formula. All we got to do is count. How far is that?
5.
So the answer there is just 5. Next question. Which one did you say, Jason?
77.
77. Problem 77 says find the distance from Q to the given line. So this time they tell us Q is -2, 1. And the line that they give us this time is y equals 1/4 x minus 3. I'm going to graph this. You don't have to graph it every time, but I'm going to. Let's see, what all do we need here? 2, -1. I'm actually going to draw my graph like way over here. And just draw a little graph so I can have more space to write out other stuff. 2, -1, we graph that first. Or -2, 1, sorry. Go over -2 up 1. That's point Q. Somebody explain to me, how do we graph this line again? Big part of the test. If you don't know how to do it, you're going to do
Go down 3.
y-intercept first. 1, 2, 3.
Go up 1.
Up 1. Now you say over.
Right 4.
So up 1, 1, 2, 3, 4 to the right 4. I'm going to run out of space on that side. So what else could I do?
Go
Go
down
down
to the left 4.
to the left 4.
So our line looks something like that. We want to find the distance from here to that line, somewhere down there. Now it looks like we might get lucky and that distance, it might hit that point right there, because does that look sort of like a right angle?
Yeah.
If we get lucky and that happens, then we don't have to go through this big long process. If we get lucky, or if we get unlucky and it doesn't happen, then we got to go through that big long process. The way we can tell if it's going to happen or not is we find the slope of this new segment right here. Well, the slope, for it to be perpendicular, has to be the opposite reciprocal of that 1/4. What's the opposite reciprocal?
-4.
-4 over 1.
And that's all.
So that tells you to go down how much? 1, 2, 3, 4, and to the right 1. That's going to put us like right there. 1, 2, 3, 4 to the right 1. So actually our line's going to go somewhere like that. So did we get lucky?
No.
Yeah. So we got to do this big long thing. 3 parts to this big long process. Number 1, write an equation. We got to write an equation of the line that's perpendicular. Number 2, find the point, find the ordered pair. Number 3, use the distance formula to find the distance. Well, we already have half of the equation. Now all we got to do is find the b. To find b, we take our slope and the q coordinates there, which were -2, 1. And we plug in y equals mx plus b. We're going to plug in here, plug in here, plug in here. That's going to leave us with just b. What do we put in place of y? What's the y coordinate of the point Q? What's the slope this time? -4 over 1, or we could just use -4, right?
Yeah.
What's the x coordinate? -2. Do a little math here. What's -4 times -2? Subtract 8 on both sides.
-7.
B equals -7. What's our equation for that line then? Y equals -4x minus 7. So that's our equation. Now we got to figure out where these two lines, this new line and the original line, what point they intersect at, somewhere in there. And all we're going to do that, take this equation, y equals this, y equals that. We just set these two parts equal to each other. How about your calculator, because we're going to change that into a decimal form probably. So my equation is just going to look like this. If I write over this grid, you going to be able to see it? Should I erase something?
You're good.
So negative 4x minus 7 should equal 1/4 x minus 3. What's 1/4 as a decimal? So we're going to get these together. I'm actually going to move them this way. It doesn't matter. We're going to subtract 0.25x on both sides. Subtract 0.25x. What's a negative 4 and a negative 0.25x give us? Negative 4.25x. Ignore the stray mark there. Minus 7 equals, what's still left on that side over there if you can see it? What? Negative 3, good. Now what do we do next? How do we move that negative 7 over to the other side? Add 7. So we got negative 4.25 x equals what? What's a negative 3 and a positive 7 give us?
Or
Positive 4. Which question, Peyton?
If you graphed out the other line, why can't you just go on to the line?
Because if I graphed them and if I used a ruler and was real precise, they're going to intersect right there somewhere, and it's not actually at one of the intersections. So when it intersects somewhere in the middle there, I can say it looks like negative 1 and 1, 2, 3.2, but I'm not being exact.
No, but for B, to find B, why can't you just go on to the graph to find?
Oh, to find the V over here?
Yeah.
You could, if you did the slope and just kept going down and found out where it crossed, you could, as long as it hits, which this one did, as long as it hits at a certain, at a whole number, at a certain point. All right, a lot of times the B will be something, 5.2 or something like that, and we won't be able to tell exactly. So yeah, you could do that also. And that's part of the reason that we graph it, is sometimes it'll make it easier to look at it and see rather than doing all the math. Next, what do we do next to get x by itself? Divide by negative 4.25. Somebody help me out. What's x? Negative 0.9. Does everybody agree with that? So that's the x coordinate of that point, negative 0.9. How are we going to find the y coordinate? Plug it back into one of them. Either this one or this one. It makes no difference. We probably don't want to plug in this one because it's got a fraction in it. So probably this one. So we're going to say y equals negative 4 times negative 0.9 minus, oops, no parenthesis there, minus 7. Just do that on your calculator. I'm guessing it comes up about 3 point something. 3.4. Anybody else get 3.4? Now it's not 3.4 because I said it wrong. It's negative, right? So negative 3.4. Are we finished? What else do we still have to do? We use those 2 points and we find the distance formula. Now I'm going to erase a bunch of this. Is that all right? Somebody have those 2 points written down? Just tell me the 2 points. Negative 2, 1. Negative 3.4. Now, have out your calculator so that you can see this. I'm going to show you how to do this all on your calculator. So this will take away some of the time. On every single calculator, well, not on every one, on the calculators, some of them, when you hit second square root, they already have a parenthesis there. Some of them don't. I don't know which calculator you have, it really doesn't matter. If yours already has a parenthesis there, Or if yours doesn't, what we want two parentheses there. So if it does, you just put in one extra parenthesis. If it doesn't, you put in two. Everything else, we're going to do this. That's squared there, this, minus in there, that's squared. At the end, when we get to the end, I want all of you to put an extra parenthesis in there. If you don't, your calculator is going to say error. So we want to type it out just like I have here. It should look just like I have here on your calculator when we're done putting in these numbers. What's our x coordinates this time?
-2 or -1.
What's our y coordinates?
1 and -2.
Plug all that into your calculator just like that. While I get my calculator.
Wait, is that -0.9?
Yep. I'm going to plug it all into my calculator just like that. The answer I get should be the same as the answer you get. If we get different answers than Ethan, which one of us are we guessing probably did it wrong?
Ethan.
Why the press got a lot of faith?
If you're having trouble plugging it in, once I get mine plugged in, tell me and I'll try to go through the steps with you. So everybody got it in there? That's what I came up with.
Read it aloud.
That's not right? 4.5, really? You guys sure?
I got 7.6. 188.
I got 4.5 this way.
I got 7.6.
So they were all wrong about you, Ethan. They should have said it was going to be me that was going to be wrong, right?
You're the one.
So, when we put this in, couple of things. When we put it in, number one, if you have a minus here and a negative here, what should you do?
Just make it plus.
Change that to plus so you don't have to put in so many different signs. All right? Your calculator doesn't understand the difference between a minus, or I'm sorry, your calculator thinks that there's a difference between a minus sign and a negative sign, and there's not. All right? They're the same thing in math, but the calculator doesn't understand that. Over here, same thing. All right? Now, what'd you guys come up with? 4.5?
5.3, 5.41.
If we go back, if I hadn't erased my graph, and we looked at that, we could tell sort of if it's about 4 or 5 units across through there. Right? So, with yours, what problem are you having? Did you have problems putting it all in, or? Now, yours is a Casio, right? So when you got done, did it give you an answer that looked like that? It gave you a fraction, right? So what we can do is on it, since it's a Casio, you do the square root. You did. Let's see here. Shift mode. We go into this. What you get is you hit shift and that button, shift that button, and it goes into there. We're going to be in here later too because you're going to want to be in this. Let's see here. I don't remember which one it is. I think we want 2. Now plug it all in there. Now it should give you the normal answer. So let me go back and I'll see. I still don't believe that I was wrong. Let me go back here, see if I put it in parenthesis. So I hit second square root, parenthesis, another parenthesis, -2 plus 0.9, close the parenthesis, squared, plus parenthesis 1 plus 3.4, close the parenthesis, square it again, close the parenthesis.
There you go.
Did it give it to you, Sandra?
Why does this desk have a graph?
Those are the way all these desks in here used to be when I was in class here. They all had that on it so that we could.
Oh, you had like markers that you could do on? That's sweet.
Now we never did it.
What is it? I want that desk.
We never did it, but that's what they were for originally, so that you could actually graph stuff right there.
That's awesome.
I want to graph things.
They have graphs on it there, so you could graph stuff. They got that bunch of graph pictures. And there used to be, which I have them at home now, this chalkboard that used to be up front. On one end there was a graph, a regular coordinate system, and then on the other end there was the round one, a polar system. See, mine's at home right now. I think I threw away. I think I used the polar graph for the top of my doghouse. And the other one I still have sitting there because I keep having ideas that I'm going to frame it in and bring it in here so I can use chalk to graph stuff to make it easier than have to have a graph. Figure it out? You sure? Ask me during the intervention if you're not sure, all right? Next question. We're wasting time. Next question. Oops.
Oh, I got one.
All right, give it to me.
34.
34. Which one?
84. 34.
34. That's why I love teenagers. Because they listen to like half the conversation.
I heard 4, so basically.
That's what happens all the time. You guys are arguing amongst each other about which number we're going to do. Who's the only one that it really matters that knows which number we're doing?
That person that said it.
Me right here. And I know, because I listened to the whole conversation, because I'm old, I listened to the whole conversation, and I know that Jacob said 34, and Ginger said 84.
I said 36. Wait, isn't that what he said? 36? Oh.
See?
He said
See?
84.
Problem 34. Yeah, so we should be done. They give us these 2 points. They want us to find the slope of a line that's parallel to that line and find the slope of a line that's perpendicular to that line. These are kind of questions I like. I guarantee there's several of these on the test. Because should we be able to find the slope of this line?
Yes.
We use the slope formula. We could graph it if we wanted, but we can use the formula. Remember the formula? You subtract the y's on top, x is on the bottom. But they have to go in the same order. So what are my y coordinates?
3 and 5.
So 3 minus 5. These are our y's. Y there. And what's our x's?
1 and -1.
Now, since we went here, we went this direction, then we got to go this direction on this one. So 1 minus a -1. What happens here on the bottom? 3 minus 5 gives you what? Close. -2. 1 plus 1.
2.
We could reduce that down to just -1. We probably don't want to. If two lines are parallel, what do we know about their slopes? They're the same. So if the slope of this original line is -1, what's the slope of this line? -1. That's one of our answers. Two lines are perpendicular, what do you know about their slopes? Opposite reciprocals. So this is the one where somebody said we don't want to change it into a regular number, because if we look right here, what's the reciprocal of 2 over 2? 2 over 2. And what's the opposite of a negative? Positive. But what would 2 over 2 positive reduce to? Just 1. So slope of the parallel, -1. Slope of the other, +1.
Yeah, doing good.
84. 84 is one of the directed segment problems. A little tougher on these, so you might want to make sure you're watching closely. And I'm going to go through it very, very quickly. I know when we did them a few days ago, it took me a while to do them. We're going to go through this one sort of real quick. First of all, am I going to be able to graph that? 84, probably not. I'm going to sort of graph it on here. I'm going to graph it like this. I'm going to graph it up here off the grid, just so that we can see what direction we're going and stuff. So we got -6, 7. That's going to be somewhere about in there. That's S. And then we got 9, 25. That's going to be somewhere way up here. That's probably even higher than that. But so that's our segment. Looks something like that. And this, they tell us we're going from S to T. So we're going that direction. Remember, somewhere through all these steps that we're going to have to do to find this, we're going to have to know for the X and for the Y, are we adding or subtracting? If I'm moving from S to T, I'm going this direction. Is the X getting bigger, or I'm sorry, are we moving to the left or to the right? So that means we add. Is our Y going up or going down? So we add. So both of them we're going to add. So we know that. That's all we really need from the graph. We're going to find point P, which is going to be somewhere on this segment. And our ratio says 2 to 3. So we're splitting it up into how many total segments? 5. And how many do we want to move? Which one? The first one, right? So we're splitting it up into 5. Stupid thing. Next. We're splitting it up into 5 segments, and we're starting here at S. We want to move to that, and we're trying to find the coordinates of that point right there. That's what we're trying to do. So how much we're moving is 2 over 5. Next thing we got to do is we got to find the slope of the original line. Well, since my graph's not very good, we can't find the slope just by rise and run. So we're going to have to use the slope formula. What's my Y's?
7 and 25.
So 7 minus 25 on top. What's my X's?
-6 and 9.
-6 minus 9 on bottom. Let's hope this comes out sort of nicely. That's -18 on top. On bottom, it's the negative, what's that, -15?
Yep.
What's a negative over a negative? Positive. 18 over 15. It's a little bigger number than I'd like, but oh well. So 18 over 15. Then we do the math. We do 2/5 times the run. Which one of these two is the run?
About 15.
The 15, the bottom. And then we do 2/5 times the rise. Which one's the rise? On your calculator, do this for me. 2 divided by 5, hit equals, then times 15. Comes out to be 6. That's telling us how much the X moves. The X moves 6 spaces. Then do this. 2 divided by 5 times 18. 7.2. That tells us how much the Y moves. What was the coordinates of the original point that we started at? -6, 7. So we got -6, and I'm gonna do this all as one step here. -6, we said we're going to do what to that x coordinate? Add, so -6 plus 6. And then the y coordinate, what was the y coordinate? 7, is that what he said? And we said we're gonna add, so 7 plus 7.2. And then we just do that math. What's -6 plus 6? 0. What's 7 plus 7.2? 14.2. That's the coordinates of point P. I think they said P, right? Yeah. That's the coordinates of point P right there.
So, this won't work for all of them because all of them they won't be so pretty. But for 15, 1/5 of 15 is only 3, right? So you can just like, does it work for perfect squares?
Let me explain something. When I do this, I tell you to do it one way, and I actually do it a different way in my head. And this is what Peyton's trying to see here. But what I found over the years is some of you can handle it. You know, if I say, oh, well, you could do it this way, you could do it this way, you could do it this way. But a lot of students can't, so I try not to tell 3 or 4 different ways. When I do this, I look at this, and this tells me this divided by this times that. But it could also mean this number divided by that, then times that. What's 15 divided by 5? 3 times 2?
6.
So when it comes out nice and even like that, might be easier to do it a different way. This one, if I tried that this way, what's 18 divided by 5? Some decimal, right? So it doesn't work out near as well. So some of them will work well that way, some of them won't.
3.6. That was so close.
All right, and then you times that by 2, and you get 7.2. So either way, when you're doing multiplication and division, which one always comes first, multiplication or division? Whichever comes first. It makes no difference. All right? It makes no difference. So if we do the division first, then the multiplication, or if we do the multiplication first, then the division, it doesn't make any difference. Does that make sense to everybody? So if there's something on one of those problems where you're doing the problem and all right, Ginger, give it to me.
I thought you said you were going to
It's 33. We're 10 minutes over. Which problem? 3.
No, I was just saying
Oh, you're telling me we went over. Yeah, I knew that. I thought you had another question. All right, make sure your names are on those. You're going to hand those in at the end of class. Go ahead and copy this down. We're going to go over this. This is what's going to be on that test. While you're copying this down here in a minute, I'm going to pass out these review packets.
I would say something, but I'm not. Yeah.
You're right.
Is that what you were going to say? That's what she was going to say.
Seriously though. No lie. No lie.
Is this the only side or is there more?
Yeah, just copy that down. That's what's going to be on this test. Not sure yet about binders or not. Really don't want to let you use your binder because Mr. A gets mad at me because when you go over to his class, you get to use nothing on the test. Test is a test, and all you should have on your desk is a calculator and something to write with. Am I right, Abby? ones that I put the asterisk beside, just something, I mean, that's ones that I think are important that nah, I'm not gonna write anything up there this time. We're just gonna jump straight to, I'm gonna just talk about it real quickly. And if you wanna jot down a couple of things, you can. I didn't wanna tell you more, I don't want you to be mad at me. Anybody mad at me all day? So, I do something else.
Will the formulas stay up there for the test?
Yeah, unless I get all excited and decide to erase them. They've been up there for quite a while now, so.
Or maybe just like a super obnoxious class. It's just like, we don't need to learn it. It's right there. And you're like, no, it's not.
I think last year the perfect square numbers stayed in that corner of my board till like the 4th 9 weeks. So, now at some point I'm gonna have to erase some things because at some point my board's gonna get filled up and I'm not gonna be able to leave stuff up there.
Use the chalkboard. When was the last time that chalkboard was read?
I wrote on, didn't I write on it when, I did write on it this year, didn't I, for your binders. Usually I write the dates the binders do up there. You can sit back
Did
there
we
if
do
you
any
want.
notes?
I'm sorry,
Was there any notes that we did not?
last time?
Yeah.
Yeah, probably. Towards J. Get a chance. Right on this, I'm gonna start going over them, be able to identify different kinds of lines, planes, whether they're parallel, perpendicular, skew, know what the transversals are. So if I gave you a picture of this box, and I said, name me 2 parallel lines, should know, maybe name this one and this one. Name me 2 perpendicular lines, maybe this one and that one. Name me 2 skew lines, you might name this one and this one down here. Or I could say, hey, I got these 2 lines right here where my hands are. What are they to each other? Parallel, perpendicular, or skew? They're parallel to each other, right? Be careful and don't think that those are skew. There is some plane that would cross through there. Next one, very important. Special angles, I guarantee I have some problem on the test that looks like this. What's those arrows tell us? Parallel. If I give you one of these angles, that angle right there is 72 degrees. Should be able to find every other angle in that picture. All right? And if we do that, how many other angles are there in that picture? 7. Guess how many points that question's worth? 7 points. Pretty big problem to be able to do that.
I miss special presidents. That's what this entire chapter should have been about.
That would have made it easier, wouldn't it? Also, I probably about guarantee you there'll be a picture on there like this one. I'm going to tell you this angle's something. This angle over here is something. How many of these other angles in this picture should you be able to find? All of them. That one's going to be worth like, instead of 7 points, it's going to be worth like 14 points. Make sure you separate things off. Don't try to look at it all together. Look at the two parallel lines, the one transversal together, the other, and the two parallel lines and the other transversal. Decide if lines are parallel. Be able to tell me if lines are parallel. If I get rid of this, don't say no because they don't have the arrows. All right. Are these two lines parallel to each other from the information that I've given you? Yeah, because we had a theorem that said if, what kind of angles are these? Alternate exterior angles are congruent, then these two lines have to be parallel. So know those theorems. Use the distance formula. We've only used it like once or twice the whole chapter, so that's not really important. Make sure you know how to do that. It probably will stay up there. Be able to find slopes of lines. If lines are parallel, what do you know about their slopes? They're the same. If lines are perpendicular, what do you know about their slopes? Opposite reciprocals or negative reciprocals or whatever you want to call them. Be able to write equations of lines, slope intercept, point slope. I probably won't care. On the test, it'll probably say write an equation. If you write it in point slope, I'll know that answer. If you write it in slope intercept, I'll know that answer. It makes no difference to me which one you write it in usually. Because if you write it in one, I'm hoping that you know how to change it over and write it in the other. So be able to write that. Again, first thing you got to do on writing those equations, if we're writing it for a line parallel to a given line, then you got to know that the slopes are the same. Slopes are equal. So you look at the slope of the original line, it's 5. The slope of the new line's got to be 5. Same thing on perpendicular, except slopes are opposite reciprocals. We just got done doing a partition of a directed segment. If I do allow you to use your binders, you should have those papers that we passed out that we worked all those steps out on, right? Be able to find the distance from a point to a line. We just got done doing one of those. Be able to find distance from or between two parallel lines. Again, sometimes those might be easier if it happens to hit right on it. Is it going to hit right on it every time? Probably not. Most of the time, not. Mr. A was just over here the other day, all upset with his students because they were doing something like this. Abby just told us that they're doing complete the square, and one of the answers was the square root of 34, and one of his classes goes, well, you can't do that. It doesn't come out even. Is most things in life going to come out all nice and even? No, you go to Walmart. Ethan goes to Walmart tonight and he is buying a bunch of stuff. When he gets up to the front and it's ringing everything up, the first thing is $3. The next thing's $5. Next thing's $4. Next thing's $2. The next thing's $7. Is that the way it works? No. You'd be lucky to find maybe a very, very small percentage of all the stuff in Walmart that's a rounded number like a $2 or $3. And usually if it's $2 or $3, it's because it's on sale or something and they've marked it to $5 or $1 or whatever. Stuff in the real world doesn't come out all nice and even.
The real world is chaotic and
Scary.
scary.
That's why your mommy, Peyton's going to let you live at home for the rest of your life, forever and ever.
She's taking me out.
Wish she
You're going to take about 10 minutes. I'm going to go sit and relax because I'm old. You getting that right, Dalton? For 10 minutes, I want you to work on this. Go through it, try to figure stuff out. You come to it. If Izzy comes to a problem she doesn't understand, circle it. All right? And then after that 10 minutes is up, so 11:55, I'll come back up front and I'll start working problems.
How do I circle the entire packet?
Same. No, look. Done. Just for that, you guys should take.
Test today, that's what we should do, isn't it? We got
I am
time.
not me. I didn't say no.
I will walk.
Start. Work. Try. Whole purpose is so you can go through and you're not sure about a problem, and you don't have to do them all one, two, three, four. Skip through it. Maybe find some stuff that you're not sure about that you want to ask questions about.